Hello, you beautiful people. This is UncleCode review and another students, another code to review, and again, Maysam and Ash. Good morning. How are you?
Yeah.
Good morning.
Hello. Good
Hello.
morning.
It's a great Monday.
Let's review.
Let's review our student code today. So, Ash, let us know who is the students. Explain to us a little bit.
All right. So, as everyone knows, actually, the Kidocode is very multinational. So now we're gonna jump into someone who is coming from Japan. So his name is Kota.
I know some of our Japanese students. One of them is Kenta.
Yeah.
Yes,
Yeah.
start with Kenta. I guess Start was the first Japanese students we registered Kidocode. I guess I remember.
I
Yeah,
think
the thing.
so.
With few of his friends, and it was very beginning of Kidocode. Okay,
Yes.
go ahead. Let us know who is these students.
All right. So his name is Kota. Now he's 13.
Oh, Kenta friend, Kota.
Exactly.
Hello, how are you, Kota? I know you. You are interested in the game development. Fantastic, great. Now he's 13 years old, right?
Yes. Now he's 13. He joined back when he was only 10 years old.
I remember in fifth floor, he always sit down on the corner of the room. Whenever I came, he was there and then working with his computer. That's great, very good. I'm glad to go through your code review today. So let us start. Yes, yes, my son. You have something
Yeah,
to
one of the very important things about him, because he didn't know English when he started. Very, very little.
Oh,
But he catch up very quickly
Perfect.
and made it very well.
very
Yeah.
good. Nice. That's true. That's true. I think
Yeah.
I think this way of learning, I became more fan of it. Honestly, when I studied the Kidocode, I get more awareness about this way of learning, constructivism, and I like to promote it again and again and again. That means when you are taking the important role in constructing what that knowledge meant to be, rather than gain the knowledge as a passive member, and then later in the future you may not be in charge of utilizing that knowledge to build something. So from now you're building this, and this way of learning English, you need to
Very
communicate.
good.
So you need to
Exactly.
communicate. That's the
Yeah.
best way.
Let's jump in it.
Rather than grammar and this and A plus, you need to utilize this skill. So that's a really good way and
Yeah.
fantastic. Very good. Let's go
Yep.
through your code, Kota.
All right.
I'm gonna share my screen. Okay, my screen is on here.
Yeah.
Let's see.
Perfect. So now tell me anything you want to add here, Misam?
Yeah, let's run the code first. It's a geoflower.
So let's run the code first. Okay, I'm gonna run the code, and I'm gonna see what's gonna happen.
Ooh.
Yeah,
Okay,
very fine
one more. Okay,
geoflower.
let's run it again. Okay, that's great. Let's look at it. So here we do have. Oh, it's interesting. Interesting. I can see the pattern. It's one dashed line. We turn it around the circle 360-degree. That's great, Kota. I like the pattern. I want to go through the code and I figure out how you did it and give you some comments. So let me go through the code, everybody. So here we do have the Tom. Thanks, Kota, by the way, to choose the legacy name. I think I'm gonna get trademark for this. So you made space speed 0. Use tracer 100. Interesting. Okay, and then I'm gonna talk a little bit about using these two together. And then def, you created a function to draw the line, I guess, and then within a loop you repeat it 100 times. So let's run it. What if I make it? Okay, now you know what? I like to understand the pattern. That's what always I do, guys. Remember that we go through it one by one. That means like we try to repeat one pattern and see how it's gonna go. So I'm gonna run one, and I'm gonna run it. So nothing happening. You can see
It's because of the tracer, I believe.
it is true. It's because of
Yeah.
tracer. I wanted to make it like a puzzle, but you answered very soon.
Oh, okay.
So we make it like it. Let's see why it's like that. Because I'm trying to let's assume that Mason never told you anything. Okay, so I'm trying to see what is going on here. I'll make it like a kind of 10. Oh, something happened. So what? It's a little bit weird, huh? Something looks weird. Why should be like that? Anyway, what I'm gonna do for now I'm gonna just comment the tracer, and I'll go for normal way that you use a turtle with the natural animation. Okay, so it's just like the way that I'm using here. So now back again to the one pattern. I'll talk about the tracer later. So you see that here now I have that pattern of 1, 2, 3, 4, 5. So when we look at the line, we can see there's a 5, there's a loop, forward 30 pixel, and then pen up and go 5, and then pen down. So repeat this. So 35, 35, 35. So that's the way that Kota you created dash. That's a nice way to do that. I like that one. It's really great. And also then later, because you want to go for the next line, you back to the origin, and then you get ready for the next cycle. So again, remember that function means modularity. We use function to make things separated. You know what? Always I have a good example, Mason and Arash, when I talk about functions. You see, look at the difference between uh, when you use jigsaw puzzles, okay, and when
Mhm.
you use
All
Lego.
right.
Yeah.
Puzzle pieces should fit within each other. There's no any other way.
Yeah.
Okay, it
Yeah.
means like when one is not there, you don't call it complete. So that's a one way of thinking. But Legos are not designed to be like that. They are totally independent than each other's. So you can connect them in different way. You may not connect them. They are complete. They are okay. So look at this two way of thinking. In computer programming, software engineering, sometimes we think like puzzle. That means we build things so coupled to each other's and should be
Mm.
all connected, even designed to be like that. That doesn't allow anything else to be connected in that area. But many times, actually most of the times, in a higher level, we think like the Lego. We think we build building
All
blocks,
right.
then we can use them in a different way.
Yeah.
Switching between these two, it's really difficult
Very good example.
and required experience, required challenges and different thinking coming from computational thinking. And you have to know when to do this and that. So that's a very important thing. Here, what Kota you have done, I see one piece of puzzle here. Looks like you use puzzle approach. That means here you draw the line and also you engage the process of back, forward, and then go for the other part. But there is an opportunity here to think a little bit of more like a kind of Lego. I mean, this is not actually a part of line. You know, it's not a part of line. It's just something else that you want to do. Maybe in another project you're going to do another thing with these lines. So it's better to me that we take it out for now, and then we just bring it here. For example, let's say go up and then do something like that. And if I run the code here again, so I'm going to get the same result. Nothing goes wrong. It's but my line function now is like Lego. Before was like two pieces of puzzle
Yeah.
together.
Mm.
You can
So-
use it now more places.
Sorry.
We can use it in other places as well.
Perfect. Exactly. We can
Yeah.
do this a lot. Yes. It's now we call it reusability. I can reuse it again and again and again. And also you can see that I can see many students code that uh, um, the turtle doesn't have this ability that forward we don't turtle always draw. I know that. Okay, so that's why you use pen up, draw, and then pen down. When I was building actually K Studio at very beginning, I had this in my mind to add this function Mesam to turtle, to add a function to turtle to be able to move without drawing. But then I decided to not do that. So because I wanted this become a challenge in coding with all the students. And now you can see all Kidocode students when they want to do that, they do this pen up, pen down, right? It's getting
Yeah.
very important. But what I want them to do is you guys can create your own functions. For example, you can create like let's call it a gap. We call it gap, let's say, and then you call it length, and then you do this, and then here is the length. So and then whenever you need any kind of creating any kind of gap, so just go and make it nicely right gap like a 5 pixel. So that's actually the name that I wanted to use when I was preparing the K portal very first version. But then I decided no, let's put a kind of challenge for students. Let's do that.
I'm
You
so
should be
mind
very
blown.
You should be very lucky because I had this decision to do something similar for forward as well to make it different than the original.
Yeah.
I'm really mind blown with this. I didn't know that you can actually define, create your own. Nice.
And also the other function that the students they can try is jump. That you can because that one also it was in my mind to do that, but this is another example that I didn't. I'm happy that I didn't. Then I go for X and Y, and then here I can just write jump 0 and 0 because when you guys create codes that require these skills a lot, so make sure one of the approach. Sometimes coders they do that. We call it helpers. Functions like jump, gap, they are helpers. So they're not like forward. Forward is a little bit different. Forward is looks like more natural things that we expect from any turtle to do that, but not we expect all the turtles to be able to jump. But these helper functions help us to write code faster and better way. So that's why programmers they build their helpers before they go for real codings, and even they have a library of the helpers that they use it in different projects because we route helpers in the way to not be coupled with a specific project. So that's a very important things to consider. So now here, I'll I'll just come down. Let me zoom out a little bit. Okay, so this is the whole thing that I have. So you see that even I like to do it like that. So you guys use it. It's good to
Yeah,
let you do not
collapse
see
it.
them. Okay. So now here we do have a lines jump, and then okay, cool. Now I have something really cool here. We got a nice thing here. So if I gotta go for 10, I'll do like a kind of 10. So now you can explain your code to people. For example, if I'm going to teach you guys, hey guys, look at this code. Let's say you know how line works. Let's say you know how jump works. Do you understand this code? Most of people says, yeah, we understand it. But
Yeah.
then let's see how line works. Then let's see how jump works. So this is a very nice way to wait for you guys to think. Programmers, they think bottom up, like the way I did it. But at the same time, they think top to bottom. It's a really nice way of switching. Switching is one of the skills that you gain in computational thinking. Think like a kind of you will be like kind of driver can drive in the left and the right at the same time. Or like for example, the instruments that I'm practicing these days, piano, you try to synchronize left and right hand. And in codings, these are a lot of things like that. That means you try to think in these two ways. And if you don't do it, you won't get the best out of training. So what else I can add here before we go for the next? Oh, I wanted to talk about tracer as well. Okay, so now look at it here, guys. I'll just back again to tracer. Technically, a proper way of what tracer does. Let me make it like this. I'll say one. I'll say one. Okay, so look at what is happening. You don't see any difference, right?
Yeah.
Nope.
You don't see any difference. I make it
No difference.
real no difference, right? So animation means, because how computer does animation, just by keep drawing. That means when you work with your computers, operating systems, there is a kind of giant loop. Keep repeating, keep drawing. So that's how we feel animation. But what if we don't draw? If we don't draw, we just see the outcome. It looks like kind of jumping to the time, because animation means give me a time, let me draw, and the next frame, and next frame, and next frame, and next frame. But imagine you play the movie, suddenly jump to the very end. They don't give time to a movie player to draw all the frames. You just jump to the very end, you're gonna see the end. In case of the turtle, this is the end. What you see here is the end. If we don't want to see, if we want to just see the result, so somehow we should ask browser or turtle, don't go through the animation. Do not draw it. Just let calculation finish, then show it to me. You get my point? I have to turn off the animation. It means I don't want animation. If we're gonna do that, one easy way is to give 0 to tracer. So, but you don't see anything. But the drawing already is done in the memory, but you don't see it because you never ask to draw it. But there is a trick to do that. Whenever you want to see what's happened by now, there is a function, you call it update.
Okay.
So now when I run it, boom. Woo.
Yeah.
So I am controlling when and where I want to see the animation, the result, how it's gonna go. So, but if I make it, for example, let's say if I go and I do it like that, see what is happening? Technically, I'm keep
After
updating.
each line.
Updating. So it looks like purposely I inject the update into the for loop. So draw, update. But what if I bring it to in the inner loop here? Technically, looks like I'm doing same.
Yeah.
Okay, no difference. So don't do this, okay? It doesn't make sense. So you can make a decision when and where you want to update, for example. So that's a really nice thing to think about it. So one is the update. But when I make it 0, so 0 means false, and whatever rather than 0 means true. But then I can give bigger number than the 1. Let's see what's gonna happen. When I say 2, I means that every 2 frames draw it. Okay, so when you say 1 means one frame, whatever frame, because depends on your screen and graphic card, your computer's capability to draw frames. Most of browsers can draw 30 frame per second, possible 60 frame per second, and then you feel it smoother. The animation is nicer. So what I'm gonna say, that means, hey, imagine I'm sleeping, you wake me up every 2 frames, and I sleep 2 frames. So then I will see faster. I feel faster because I sleep, I wake up, more changes happen rather than I keep checking every one frame. So let's make it 2. Maybe you don't feel it, but I feel it. Let's make it 4. You see?
Yeah,
Oh,
faster.
yeah.
Faster. Let's make it 8.
A lot faster.
Okay, so you can continue, but there is very important that if you suddenly put a big number and that the number jumped out of come out of the range, that things happen, you won't see again anything. So it's very important that you figure out, play around with this number. But there are some bugs in tracer functions, by the way, in this Python. So it's a little bit trial and error, but you can play a little bit with numbers like 2, 4, 8, 10. They're gonna give you good feelings. And let's say so, but if you want to get it super fast, it's better to make it 0 and then update it in the way that you want it, or you play like this, just make it like that. Get a faster result
Cool.
to do this. So now we go for the next code. Okay, so anything for this, Mesa?
This is no, it's fine. Just play it.
Okay, so Kota, first of all, good job for the previous code. It was nice using the functions. And then now I suggest you to rewrite your code when you have time. But not only rewrite the code, think about why I suggested those changes. That's more important, honestly. So we go and run this. Okay, pyramid. Okay, fantastic. Oh, that's not. It looks like a night, and here is face the moon.
Yeah.
Sunshine.
Yeah.
And my blue t-shirt is Kidocode blue. You know, you see. Thanks, Kota. So you knew that one day I'm gonna review your code in a day that I have a blue shirt. Wow, how you do that? So let's see what we can do here. So you made the speed 0, okay. So but now you know that the speed 0 is like you play around with tracer and the speed 0. You know, both of them possible. Okay, and then begin fill. So now we have a 4 loops. Let me comment this part. You did 4 because you wanted to back to the corner, and then okay, let's make it slow a little bit. 10.
Yeah.
Okay, and then heading 0. You wanted to make it again 0. So you didn't want to calculate how many degrees.
Yeah.
Okay.
Avoiding the trouble.
That's a good way. Okay, it's smart. So now let's. And then here you did the 50 pixel and then 90. Oh, okay. How you got 50 pixel? I like to know that. And then 30. And okay, you must definitely have done some calculation. I mean, you know things about trigonometry to do that, because if you think here is 50, because this is 60 degree, because you draw equilateral triangle. So here is 60, so here is 50. This means here is 70, and this means 20. So the length of this, you can use the sine of 20 multiply by the length of this that you use 150. And then I guess it's gonna be probably gonna be 50, and then here will be the cosine, or use the Pythagorean theorem. So, but I guess you did it on a paper or calculator or somewhere, because
Or maybe by try and error.
because
Yeah.
it's possible. Because yeah, you're right, Sam. Because I can see some
Yeah.
here,
Yeah.
maybe, but let me give you a few hints about it, and then we improve this. First of all, what I noticed immediately is this. Let me comment this one. Okay. Here, what if I make it 3? Because it's triangle. Let's see what's gonna happen. So, kind of funny shape will become, because you're supposed to draw this here, right? That's why you route total back to this place. But there is something else interesting. Let me comment now this part. You see here what you've done. Here you started to do one forward, which is this. Okay, let me zoom to the code. So you did one forward, then 90, another forward 50, turn 90, 30, and then you call end fill. So it means Turtle has this ability to connect end and start point and end point by itself. You don't need to back again here. That's a very important thing. So if you understand that, because you did it here, so you can utilize this for your blue triangle to not have the for loop with the 3 or the 4 times. So let's see what I mean by that. Okay. What I like to do is, okay, what if, because you need Turtle to come here, right? You need Turtle to come here. What if we think of this pyramid in different way? What if we do it like, oh gosh. So let's say let me bring it back to that 4 again. Okay, what if you do this? What if you move from here, goes here, then go here, then call end fill? Because Turtle knows, Turtle will give you this triangle. So 1 forward, 1 right, another forward. So 3 steps. Then from here, you back here and back here, and then fill it. Like
what if we draw the blue after the light blue? When we got to the peak of the
or that one is possible. That one was possible. You draw that one, then you do this. So either this or that one. I go for this one because this doesn't need calculation. It's the easiest part of the problem. At least I reduce the problem to a smaller version to do the challenge a little bit later. Both possible. I prefer the blue one first. So what I do, I will just go back. And there's one more thing is important. From this 150, I make a decision. What should be this length of the other and degree of the other shapes? So I will just close these things, go forward, left this, and then again another forward, and then end fill. So let's see what we have by now. Okay, so that's what I got here. So now what I have to do, I have to back 180 degree. You see, I don't need to do any calculation. Definitely, I'm correct. 180 degree, exactly, because I'm moving here. 180 means reverse the direction. So I'm gonna go for the right, for example, 180. So I'm gonna run it. You see the now Turtle is moving down. So then I will change the color. Maybe I change the color before this to be able to see the Turtle. So now I'm here. Great. So what I do, I will do another forward 150. Because I'm just heading back. Even I can do backward, I can do backward as well. I can do the backward, to just come down. I will come down here and then use that triangles, right angle. So now here, I'm gonna go now to the left. So here is the very important part. So you did 50 pixel. It doesn't matter how many pixels, whatever you like, because then you have to figure out the 90 degree and calculate the rest. So what I'm gonna do, I will do this one. Here now is 60 degree, right? So now I'm here. So if I turn left 60 degree, let's see what's gonna happen. I turn right. Oh, sorry, left. So now I'm just aligned with the horizontal. So now what I like, I can make a decision. You choose 50 pixel, Kota. You can choose, anybody can choose anything. It depends on how you like to draw your pyramid or the way of the perspective. What I like to do, I want to go 60 degree. I want to just, because it's 60, I want to do the 60. Okay, because 60 degree technically is easy. Sine 60 is a good number. So now what I'm going to do is I will just go another 60, so plus 60. Then I will be like this. Then now I have to do the magical part. That means I have to do some mathematics here. So let's say for now I do trial and error. I'm just gonna go 50 pixel, okay, 50 pixel, and then here, let's see what's gonna happen. So 50 pixel, and then I want to go turn 90 because you wanted 90, so that's why I'm following that 90 degree. I guess maybe.
Do we need that, or we just can end fill now?
If you want the 90, I'm going to follow what he did with the 90 degree.
Okay.
But you're right. For example, if I'm gonna do this, did I do the begin field? No. You know what? If you do that one, definitely you can do that. See, it will be like that. Okay. Yeah. But I want to make sure. I want to do the 90 degree. I guess in the question was 90 degree, right? I guess this 90 degree is set for that because we design questions, we use Pythagorean theorem a lot. So that's why I feel there should be a reason that they did the 90-degree. So what I do before I do the end fill, I will do the right 90-degree, left 90-degree. See what's gonna happen. And I'll do like, let's say, I don't know, just a number. Let's see what's gonna happen. So you see the problem here. I think that was the challenge behind these questions, that they
Exactly.
used the way to be 90-degree to do that. So now it's very simple, because here I know that this is 60-degree. So I'm going to make a 60-degree. So if this is going to be 60, if I'm going to draw the line in a way that here be 90-degree, so 90, so this will be 30-degree. So this is 30-degree, this is 60-degree. So what should I do? This always is equal by sine of cosine of this 30-degree and sine of this 60-degree equal and multiply by hypotenuse. So here is 150, and the sine of the 60 is half. So half multiplied by 150 will be 75. So if you're gonna do that, it will be like, instead of the 50, it should be 150 divided by 2. And then let's see what's gonna happen here. Okay, so now I got that kind of 90-degree. Okay,
Yeah, I got exactly to the
Yeah.
peak.
just hitting. So what I did, I just used trigonometry, and I multiply hypotenuse by half by 0.5, because 0.5 is the sine of 30. And then, so now if, for example, let's say I'm going to do the calculation to get the sine of 60-degree as well. For the 60 as well. And then which give me around 0.7, I'm going to do that here. Then you can do it. So let me print it here. I guess it's good. Just let me remember that if we do have math, import math,
Yeah.
we have it, right?
Yep.
So print math.sign work, Maysam? Do you
Should
remember?
work. But it's working based on the radio.
Oh, radian. Okay. Math, or it's math? Correct. So is it? You said it's radian.
Let me double check.
Yeah, it seems it's radian, because it looks like. So let's put 3.14. Okay, 3.14 is almost 0, so it should be radian. Or I will do the math.pi. Pi. I've been too much in JavaScript. So then, yeah, I think that's the case. Or let me do this. Let me do this for now, because I'm not sure about it here, that if we're gonna have it or not. So I'm gonna go for degrees. So I'm gonna say 30, and then sine 30. Wait. So sine 30. So it's half. That's what with it. Now we go for 6 sine 60. So it's 0.86, right? So I'm gonna back again to the code. Where's the code? 0.86. So here, what I do is this. I will go this times by 0.86. Okay, and end fill.
Yeah.
So I got exactly the shape. Exactly the shape. So he remember here, if I want to make it, okay, multiply 0.5. Okay, so that's the whole thing. So this is sine 30 and multiply by 150, and this is sine 60 multiplied by 150. Okay. That's the exact code.
Nice.
So we have it here.
Perfect.
So this is the one way that we can really think about all these kind of codes and utilizing the mathematics behind them. I think that was the whole point of these questions as well. Perfect. Very good. So We consumed 30 minutes for this code review. Kota, your code was nice and interesting for your coding. Great. So that's all. That's all I have
Very good.
Well
to
done.
to remind all the students that, again, as always I say, that when you harvest and cultivate your codes, you're gonna get more new things and beautiful things. You can change them, you can restructure them, you can always keep them better and better. One of the things that I like about coding, this ability that always I can improve my code, teaches me that there's no one perfect point. There is a progress. And this progress is the secret of happy life, I guess. So learn it from here and then apply it to your life everywhere. So that's all, everyone.
Very
It was
good.
All right.
very good. So now we're going to tell you something important, very important, Kota. And we have to
Yeah.
tell you what we should tell you. Kota, did you know that you are programmer?
Programmers.